Alright guys, so look at this reasoning problem and it's kind of based on what we know about intersecting chords and segments. So it says in the circle below, diameter CD is perpendicular to the chord AB. So CD and AB are perpendicular. So CD is perpendicular to AB. So the angle they make is 90 degrees between them. It's right angle. And then the radius OB and OA are also drawn. So the radius is the distance anywhere from the outer circle. So for example, from point B to the center of the circle, point O. That's a radius. This is also a radius from point A to the center of the circle, point O. This is also a radius from the outer circle, point C to point O. So any point we take on the circle, and if we draw a line to the center, it's the radius. Alright, so part A, we have to prove that triangle OEB is congruent to the triangle OEA. So we have to show that this triangle OEB, this one, is congruent to this triangle. Okay, now in order to show that, what we're gonna do is we're going to look at the sides of the triangle. What do we know about the sides of the triangle? So as of now, we know that this distance are the radius. So this is radius, and this is also radius. And then these radius is the same exact thing. They have the same magnitude, so they're congruent. So we know that this side is congruent to this side, okay? And we also know that this side of the triangle, this side OE, is congruent to itself. So we know OE is congruent to OE because of reflexive. Because of reflexive. We also know OA is congruent to OB because they're both radius and they are equal. Radius are equal. Alright, now what we have is we know one of the side given in pink and the purple side. Now if we look at both triangles, they're both right triangles. They're both right triangles. And one of the theorem that we know that shows triangle congruency is the hypotenuse leg theorem, which states if we know the hypotenuse of two triangles are congruent, for example, for this triangle, this is the hypotenuse, is congruent to the hypotenuse of this triangle, and if we know one of the leg of the triangle are congruent, then the triangles must be congruent. Okay, so let's go ahead and write our conclusion for part A. For part A, since we already know that the hypotenuse are congruent, these sides are congruent, so we have a hypotenuse congruent, and we also know that sides OE, which is this side, this is the side OE congruent, then by hypotenuse leg, HL, hypotenuse leg, triangle OEB, which is this one, this is the triangle OEB, is congruent to the triangle OEA, which is this one. Triangle OEA. That's how we show that triangles are congruent. Okay, so that's part A. Now, for part B, what does your answer tell you must be true about the line segment AE and BE, and explain why? So for now, we know the triangles are congruent. Now we want to know what's that means. What's that tell you about this line segment AE and this line segment B? Now AE is coming from this triangle and BE is coming from this triangle. And we already know these two triangles are congruent. That tells you that if the triangles are congruent, that tells you that AE must be congruent to BE because of CPCTC. Congruent parts of congruent triangles are congruent. Since we already know these triangles are congruent, then the legs, the other side, must also be congruent by CPCTC. Okay, let's move to part C. It says if the diameter of the circle is 20, so if the diameter is 20, then the radius is half the diameter. So the radius will be half of 20, which is 10. The radius of the circle is 10. CE is positive 4. We have to find the length of the line segment AB. So let's go ahead and let's put that information. We know the radius is 10. So this is the radius. O to A and O to B, these are the radius. This is 10. This is also 10. Okay. Now, we also know that CE is positive 4. This section, the little one right here, this is positive 4. We also know that this distance from this point C to O, this is also a radius, and that's 10. All the radius is same. So this is 10, that's positive 4. So this distance right here from O to E must be 6. It must be 10, take away positive 4, which gives you 6. So this is 10, that's 4, that must be 6. Alright, and then we also know that this distance from O to B, that's a radius, and the radius is same across the circle, so it's going to be 10. So we have 10, we have 6, and we have positive 4. These are the information that we have. Now let's go ahead and let's simplify it a little bit down with the numbers. So as of now, what do we know? Alright, let's see. We know that this distance, we know that from this point to point D, the whole thing is 6 and 10, 10 plus 6, which is 16. So the distance from O to E is, the distance from D to E is 16. So let's go ahead and let's replace all these by 16. We already know this distance is 16, so I'm going to use this color. So this is 16. This gives positive 4. Now these two distances, since they are congruent, AE is congruent to BE, AE is congruent to BE, so we're going to call this X. If this is X, then this must also be X because they're congruent. Okay, now we have the 4 segments of the 2 chords that intersect. So this chord intersect with this chord, chord AB, since chord AB, which is the purple one, intersect chord CD, which is this one, then that means we can apply the intersecting chords and segments, which tells you this, take this little segment, take this segment positive 4. You know what? Take this segment, one of the segment of AB, which is X, multiplied by the other segment of the same line segment AB, which is X, should be equal to, for the line segment CD, this portion, which is positive 4, times it by this portion, this segment, which is 16, times it by 16. So this is the equation that we have in order to find what X is. Now X times it by X is X to the powers of 2, equals to 4 times it by 60 is 64. And then in order to find X, we take square root on both sides, so that X will be square root of 64, which is positive 8. So X is positive 8. So let's go ahead and replace the X by positive 8. So this is going to be positive 8. This is also going to be positive 8. So this is X positive 8. This is positive 8. Now the question C is asking the length of the line segment AB. So the length of the line segment AB would be the length of the line segment AE plus the length of the line segment EB. So if we add this little 2 segment, we'll get the entire segment AB. Now AE is positive 8, EB is also positive 8. So AB must be equal to 8 plus 8, which is 16. So the line segment AE is equal to positive 16. Alright guys, thank you.